T-minus
3, 2, 1.
Atlas engine ignition.
Liftoff of the United Launch Alliance Delta IV Heavy rocket.
At Space Launch Complex 37, a Delta IV rocket is fueled and ready to launch the WGS-8 mission for the United States Air Force. Good evening, and welcome to Mission Control at Cape Canaveral Air Force Station in Florida. I'm your host, Mike Underhill. I'm a propulsion engineer at United Launch Alliance in our Human and Commercial Services organization. Today's 49-minute launch window opens at 6:53 p.m. Eastern Time, and our live mission coverage will continue through spacecraft separation, scheduled to occur about 42 minutes after liftoff. The launch count is currently in a planned 30-minute hold. There are 3 planned holds in our 9-hour launch count. The planned holds give the team time to conduct final systems checks and resolve outstanding issues prior to entering the terminal count. At this point, the team is not working any issues. Later in the broadcast, Captain Ernesto de la Peña, Chief of Cybersecurity for the Air Force's MIL Satcom Directorate, will join me to discuss satellite communications and the capabilities of the WGS satellites. I'll also be joined by Arvel Chevelle from satellite manufacturer Boeing. This evening, we will also be hosting a game of launch trivia on Twitter. At 6:45 p.m. Eastern, questions will be posted to ULA's Twitter handle @ULALaunch. The first participants to correctly reply to each question, along with the hashtag WGS8, will receive a prize. Each participant is only eligible to win 1 trivia round. Stay tuned after liftoff to hear the questions, answers, and winners announced. Kathy Winters, the 45th Space Wing's weather officer, recently provided the final forecast, and today's weather is within the launch commit criteria. The probability of violating launch constraints is 10%, the ground winds are 5 knots out of the east-northeast, and the temperature is 67 degrees Fahrenheit. So with that favorable forecast, we are proceeding towards a planned T0 of 6:53 p.m. Eastern. This is Delta Mission Control at T-minus 4 minutes and holding. Today's launch will deliver the 8th Wideband Global Satcom satellite. Built by Boeing's Space and Intelligence Systems, WGS is an important element of a new high-capacity satellite communication system, providing enhanced communications capabilities to U.S. and allied warfighters for the next decade and beyond. Each WGS satellite provides more wideband communications capacity than the entire defense satellite communications system. The constellation WGS is augmenting. For most missions, our customers provide artwork which is added to the payload fairing. For WGS-8, the artwork represents the 8th WGS satellite on what was originally supposed to be a short gap filler program. WGS-8 is represented by the 8 ball, while the first 7 WGS satellites are represented by pool balls 1 through 7. Today's flight will take a southeasterly heading away from our launch pad here at Cape Canaveral. Let's take a look at what else we can expect to see today.
The following profile details the important events of this mission using approximate times.
5, 4, 3. We have ignition. 2, 1, 0, and liftoff of the United Launch Alliance Delta IV rocket.
The Delta RS-68A main engine and 4 strap-on solid rocket motors ignite to lift the vehicle away from the pad. Shortly after liftoff, Delta begins its initial pitch and yaw maneuvers to attain the proper ascent profile and minimize aerodynamic loads. Delta IV reaches Mach 1, the speed of sound, at 34 seconds. At 46 seconds, the vehicle reaches maximum dynamic pressure. The strap-on solid rocket motors, or SRMs, burn out approximately 91 seconds into flight. At 1 minute 40 seconds, the first two SRMs are jettisoned. 2 seconds later, the remaining two solid rocket motors are jettisoned. The payload fairing is jettisoned at 3 minutes 14 seconds. Approaching booster engine cutoff, the Delta IV is burning propellant at the rate of approximately 998 pounds per second, flying at more than 111 miles in altitude and 224 miles downrange. Booster engine cutoff occurs just under 4 minutes into the flight. 6 seconds after booster engine cutoff, the first stage is jettisoned. Second stage main engine ignition takes place at 4 minutes 15 seconds into the flight. The second stage and WGS satellite are now in the first burn. Following the second stage main engine cutoff at approximately 20 minutes, the mission enters a coast phase. Just over 29 minutes into flight, the second stage main engine is reignited for the second burn. Following the second stage main engine cutoff number 2, the second stage and payload enter a coast period in preparation for spacecraft separation. At 41 minutes 44 seconds, the second stage releases the Wideband Global Satcom satellite for the United States Air Force.
Mission capable. Recommend placard 6 Alpha.
ALC, verify wind monitoring system is set to placard 6.
Verified.
Built in Decatur, Alabama, the Delta IV Medium Plus 5.4 includes a common booster core powered by an Aerojet Rocketdyne RS-68A engine and 4 orbital ATK solid rocket motors. An Aerojet Rocketdyne RL-10B2 engine powers the Delta cryogenic second stage. WGS-8 is protected during ascent by a 5-meter diameter payload fairing. On November 21st, the encapsulated payload fairing was transported to the Mobile Service Tower, or MST, at Space Launch Complex 37 and made it to the Delta IV rocket. Nearly 8 hours ago, final preparations began at Space Launch Complex 37. Using 40 hydraulic cylinders at pressures nearing 3,500 psi, the 10 million pound MST was raised 8 inches and rolled back, revealing the Delta IV launch vehicle. Using a carriage transporter system traveling at about a quarter mile per hour, it takes about 25 minutes to roll the MST to its launch position at 345 feet north of the Delta IV rocket. The Delta IV rocket stands 217 feet tall, or about 21 stories high. The RS-68A main engine and 4 solid rocket motors combine to produce approximately 1.1 million pounds of thrust at liftoff. About 4 minutes later, at stage separation, it weighs just 10% of what it did at liftoff. This evening's flight is dedicated in memory of our colleague, friend, and adventurer, Michael Carr. During his 35-year career at Sandia Laboratories, Boeing, and United Launch Alliance, Mike played a role in more than 300 space launches. Throughout his accomplished career, he was Director of Communications and Tracking System Development on NASA's International Space Station, Global Missile Defense Interceptor Chief Engineer, followed by a position as the Delta II and Delta IV Avionics Director, and finally, Director of Space-Based Range. Mike was well respected by his peers, customers, and suppliers for his technical knowledge, business acumen, and insightful leadership. He was never too busy to take the time to mentor and encourage others on his teams. Mike's greatest talent was his incredible ability to inspire his coworkers to achieve far greater things than they ever believed they were capable of doing. He truly was a motivator and a person who changed people's lives.
L minus 10 minutes.
RC verifies solar radiation limits acceptable for launch.
Before today's launch, let's take a look at the amazing upgrades that WGS has made to improve military communications around the world.
Virtually every military mission relies on satellite communications. From data gathered by UAVs to teleconferencing between military leaders, WGS is the backbone of our military's ability to communicate. One satellite by itself can't service the entire globe, so it's really important to have an entire network of satellites to make sure that we have full coverage. WGS is the satellite network used by the military and our allies to communicate across the world, anytime, anywhere. We want to protect the satellite as much as we can, so WGS is going through a fleet-wide upgrade right now by uploading new software and modifying the ground segment to allow continuous communications that aren't interfered with. One of the major things that the military has been looking into is how to make satellites more resilient to jamming. Sources of jamming can range from an adversary that's trying to affect your communications path to someone who is accidentally in that bandwidth. One of the enabling technologies for anti-jam capabilities is the use of phased array antennas. By adjusting the power and timing of each of the antenna elements, we're able to create a shapeable beam to avoid the jammer that allows for warfighters to stay connected wherever they're located. When you take into account satellites that allow upgrades through software and the ability to provide anti-jam protection, it all allows us to provide a more resilient system that the military can count on.
L-8 minutes.
All right, I'm going to set my time to...
This is Delta Mission Control at T-minus 4 minutes and holding. We remain in the planned 30-minute built-in hold as preparations for launch continue. In a few moments, launch conductor Ed Kidda will poll the launch team for the final go to pick up the countdown. 32 engineers and managers are polled for system status and readiness to proceed. This is the final status check before launch for all Delta vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Ed Kidda performs the final polling of the launch team.
L-7 minutes.
Status check to proceed with terminal count. MEQ.
Go.
MEA.
Go.
HYE.
Go.
LOX 1.
Go.
LOX 2.
Go.
VP.
Go.
P&E.
Go.
BP.
Go.
ATC 1.
Go.
PEA.
Go.
Fuel 1.
Go.
Fuel 2.
Go.
TM 1.
Go.
ATC 3.
Go.
TM 2.
Go.
FMA.
Go.
VE.
Go.
EEA.
Go.
GE.
Go.
SYS.
Go.
DSE.
Go.
Timer.
Go.
ECS.
Go.
QE.
Go.
USO.
Go.
OSM.
Go.
VSE.
BSE is go.
ALC.
Go.
AC.
AC is go.
RC.
Clear to proceed.
Launch Director.
Launch vehicles ready to launch.
Mission Director.
You have permission to launch.
Proceeding with the count. MEQ. Establish swing arm lock pins pull.
Active.
SY. Establish record on change list activated.
Activated.
Polling is complete and the launch team is given the go for launch. The countdown will resume approximately 2 minutes from now. At T-minus 4 minutes and counting, the team will enter the terminal count and will begin securing the second stage liquid oxygen tank. At T-minus 3 minutes, 32 seconds, booster liquid hydrogen and liquid oxygen tank securing is started, which includes closing the propellant fill and drain valves. At T-minus 3 minutes, 32 seconds, vehicle transfer from ground facility power to its own internal battery power will be complete. At T-minus 3 minutes, the vehicle ordnance system will be armed, and the booster liquid oxygen and liquid hydrogen propellant tanks are verified to be at flight pressure and flight level. At 2 minutes prior to liftoff, the team will verify that the hydraulic system is pressurized, as well as confirm booster, DCSS, and flight termination system battery voltages. At T-minus 1 minute, 20 seconds, the team will begin securing the second stage liquid hydrogen tank. At T-minus 60 seconds, the eastern range readiness is verified. At T-minus 50 seconds, the DCSS liquid hydrogen tank is secured at flight level. A final launch vehicle and spacecraft status check is conducted at T-minus 30 seconds. At T-minus 15 seconds, the ROFEs, or sparklers, are ignited to burn off the excess hydrogen at the base of the vehicle. Liftoff will occur at T0. After liftoff, we'll hear the voice of Patrick Moore providing launch vehicle ascent data.
Upper stage lock securing started.
Vehicle transferring internal.
3 minutes, 50 seconds.
The countdown clock has resumed, and we are go for launch at 6:53 p.m. Eastern.
Internal complete.
Second stage lock secure at flight level.
CBC lock secured.
CBC LH2 secured.
3 minutes, 7 seconds.
CBC pre-press started.
T-minus 3 minutes.
Vehicle ordnance arming.
CBC locks at flight pressure and flight level.
Vehicle ordnance armed.
T-minus 2 minutes.
TPA script running. Hydraulic press at 4,000.
CBC LH2 at flight pressure and flight level.
T-minus 90 seconds. The launch vehicle, payload, ground systems, and eastern range are go for launch.
T-minus 1 minute, 20 seconds.
Upper stage LH2 securing started.
T-minus 1 minute, 10 seconds.
T-minus 1 minute.
Go. Rock, report range status.
Range green.
50 seconds.
Upper stage LH2 secure at flight level.
45.
Launch enabled. GE, main power off.
Main power off. $30.
Status check. Go Delta. Go WGS-8.
25.
Green board.
Flight lock in. SRM TVC blowdown.
15.
Prophy ignition.
T-minus 10, 9, 8, 7, 6, 5, 4. We have engine ignition. 2, 1, and liftoff of the United Launch Alliance Delta IV rocket carrying the WGS-8 mission for the United States Air Force.
R68 performing well. Fuel injector and chamber pressure looking good. 20 seconds into flight. Burn profiles on the 4 solid rocket motors all looking good. 30 seconds in. Mach 1 vehicle is now transonic.
You're hearing the voice of Patrick Moore providing launch vehicle ascent data.
Now passing max Q, maximum dynamic pressure. RS-68 continuing to perform well. Chamber pressures and injector pressures looking good. Burn profiles on the 4 solid rocket motors also looking good. Now passing 1 minute into flight. Approximately 30 seconds remaining in the solid rocket motor burn. Delta IV is now 12 nautical miles in altitude, 10 miles downrange, traveling at 2,000 miles per hour. 1 minute, 20 seconds in. Standing by for SRM burnout shortly. And we have solid rocket motor burnout. Standing by for separation. And we have good indication of separation of all 4 solid rocket motors. The Delta IV rocket now weighs just half of what it did at launch, burning propellant at a rate of almost 2,000 pounds per second. 1 minute, 55 seconds into flight.
Roger.
The upper stage ACS press valve has been opened. 2 minutes into flight, now passing Mach 5. Delta IV is now 35 nautical miles downrange, 40 miles in altitude, 55 miles downrange, traveling at over 4,000 miles per hour. 2 minutes, 20 seconds into flight. RS-68 continuing to perform well. Fuel injector and chamber pressures looking good. 2 minutes, 30 seconds in. Vehicle body rates remaining stable. 2 minutes, 40 seconds in. And the upper stage engine has begun the LOX pre-start sequence. One minute to MECO. 3 minutes into flight, now passing Mach 10. RS-68 continuing to perform well. Fuel injector and chamber pressures look good. Standing by for payload fairing jettison momentarily. And we have indication of payload fairing jettison. 3 minutes, 20 seconds into flight. Three minutes, 30 seconds in. Vehicle is now 80 nautical miles in altitude, 190 miles downrange distance, traveling at 8,900 miles per hour. 3 minutes, 40 seconds into flight. Standing by for booster throttle down shortly in preparation for MECO. And booster has begun to throttle down in preparation for MECO as expected. Standing by for MECO. And we have MECO, first stage engine cutoff, standing by for separation. And we have good indication of stage separation. NEDS is deploying, standing by for main engine start. And we have main engine start on the upper stage engine. Chamber pressures and injector pressures look good. This is the first of 3 planned burns for today's mission. First burn should last approximately 15 minutes and 30 seconds. Vehicle body rates have recovered well after initial startup transients. RL-10 continuing to perform well. Chamber pressures and injector pressures look good.
This is Delta Mission Control at L plus 4 minutes, 57 seconds. We've just heard Patrick Moore report the successful execution of the early events of tonight's flight, and all systems continue to operate nominally. The Delta IV second stage and WGS satellite are traveling over the Atlantic Ocean in a southeasterly direction away from the coast of Florida. The mission is now in the first of 2 planned RL-10 engine burns. This burn will last approximately 16 minutes. I'm joined now by Captain Ernestus de la Peña. Captain, thanks for joining me.
Thanks for having me, Mike.
So, what role does the WGS warfighter does the WGS system, play for the warfighter?
So WGS, or Wideband Global Satcom, provides 24/7 worldwide communication to the joint warfighter. WGS is unique in that it has the ability to cross-band frequencies within the wideband range of the electromagnetic spectrum. Meaning to say, and I'm overgeneralizing here of course, but user A operating on frequency A can directly connect to and communicate with user B operating on frequency B.
So for our viewers that may not have a detailed knowledge of how satellite communications works, can you explain it a little bit?
Sure. Well, it all starts with a communication that needs to get from point A to point B. In the world before satellite communication was developed, we accomplished this through signals, messengers, wires, or terrestrial radio. As you can see, you're limited to either a direct connection or line of sight. By line of sight, I mean I see you see me, we communicate. In order to overcome these geographic obstacles, you can actually put a satellite out in space and leverage that system as a relay to get your message from point A to point B, regardless of geographic separation. Now, Arthur C. Clarke, better known for his science fiction work on 2001 Space Odyssey, is oftentimes credited with proposing this concept that we're putting into practice today.
Yeah, so it definitely provides a really unique capability for the warfighter. So can you, that's really impressive, and can you tell us a little bit more about the satellite itself?
Sure. Well, for starters, the satellite itself weighs about 7,600 pounds. That's equivalent to a 3/4 ton pickup. For perspective, that's your F-250, your Chevrolet Silverado 2500. Additionally, when fully extended, WGS's wingspan is 135 feet. That's greater than the wingspan of a Boeing 737. And once in orbit, the satellite itself will actually be traveling about 22,000 miles from the surface of the Earth. It'll be in geostationary orbit. And by that I mean that in the time that it takes for the satellite to make one revolution about the Earth will have rotated once about its axis. But in order for that to happen, the satellite has to be traveling at approximately 6,800 miles per hour. To put that into perspective, your average bullet travels around 2,500 feet per second, or 1,700 miles per hour. So we essentially have something that weighs as much as a 3/4 ton pickup, as bigger than a Boeing 737, traveling at an altitude that's insanely high, and traveling at the speed 4 times of a bullet. If you ask me, Mike, I think that's pretty impressive.
It's just absolutely amazing. So what is the role of the WGS program in the Air Force's mission?
So I don't know if you had the opportunity to watch CNN the other day, but they aired a special, and it more or less chronicled the day-to-day activities of the Joint Space Operations Center out at Vandenberg Air Force Base in California, in addition to some of the operations conducted by Schriever Air Force Base out in Colorado. But I want to draw your attention to what they chose to name the documentary. It was terse and effective, in my opinion. War in Space. You see, space is becoming increasingly congested, contested, and competitive. So you have to continuously push the boundaries in terms of technology and capability in order to maintain a level of presence in space. I mean, the Air Force mission is to win at all levels of conflict in any domain. Launching WGS-8 today helps fulfill that overall effort.
So how does this mission fit within the Space and Missile Systems Center?
Well, aside from satellite communications, the Space and Missile Systems Center is actually responsible for fulfilling a myriad of space-related needs, to include acquisition of space launch vehicles like the Delta IV that WGS-8 is taking a ride along today. But in addition to that, SMC is involved in various program offices to include GPS, which is responsible for your position, navigation, and timing, weather, early warning, and all their associated ground counterparts. So it's pretty comprehensive.
Absolutely. So what is your role specifically with WGS?
So as Chief of Cybersecurity for MIL Satcom, I help to ensure that the data that's traveling through MIL Satcom systems is secured at the appropriate level. This applies to both the ground segment that's responsible for the command, control, and transmission of the actual data, in addition to the space vehicle itself. But from a MIL Satcom perspective, safeguarding the confidentiality, integrity, and availability of the information traveling through these systems is of critical importance. But overall, I mean, obviously I don't do this by myself. I'm part of an exceptional team out at MIL Satcom. We're able to provide 24/7 worldwide communication to the Joint Warfighter and our international partners.
Well, thanks so much, Captain, for sharing all that really great information. We need to return back to the mission now, but stick with me as we'll soon be announcing our trivia winners.
Sounds good.
Now passing 11 minutes into flight. RL-10 combustion chamber pressures, fuel and oxidizer injector pressures all looking good.
This is Delta Mission Control at T plus 12 minutes. We're approaching the end of the first of two planned RL-10 second stage engine burns. The Delta IV and WGS satellite are flying over the Atlantic Ocean off the west coast of Africa. Our next event, the first main engine cutoff, or MECO-1, is scheduled to take place just about 7 minutes from now. While we wait for the next mission event, let's take a look at a video highlighting the important capabilities of the WGS system.
While Boeing engineers build the next wideband global Satcom satellites, the first satellites currently on orbit are providing global communication for the Department of Defense.
It offers over 3.4 gigabits of information throughput. This system actually operates in the Ka and X bands, which is critical for communicating with various armed services.
Another important advantage the WGS satellite provides to armed forces across the globe is anti-jamming capability in parts of the world known as highly contested areas.
WGS has the ability to shape some of its beams to a specific communications area on the globe. So whether it be a shipping lane or whether it be around land masses, it also has the ability to move and pivot its communications beams to be able to follow communications users or to avoid jamming.
WGS satellites allow increased global cross-communication for all branches of the U.S. Armed Forces serving military missions or humanitarian relief efforts on land, in the air, and at sea. And now, thanks to a program created by the Department of Defense, the WGS satellite system has been expanded to partner nations.
The 6th satellite was actually funded by the Commonwealth of Australia, and the 9th satellite was funded through a consortium of 5 different member nations: Canada, New Zealand, Luxembourg, the Netherlands, and Denmark.
Bringing our partners into our programs together and building these relationships and building these systems together really solidifies interoperability. So now we're using the same system, we're using similar terminals, we're able to communicate better across the battlefield.
Access to the WGS system offers partner nations not only increased communications capability in the field, but convenience in their budget.
They can put in only what they need in terms of buying into the system, and then they get global access through the entire constellation. It allows them to buy in without investing in the infrastructure, which includes the launch costs and the mission commanding and control.
There's an incredible amount of pride to be able to take this and build this communications satellite and provide this capability to the DoD and its allied partners.
ECS, LC.
Go ahead.
Status at step 110. ECS systems stable, ready for pad
That's
entry. Roger. And fuel 1 had already reported that storage tank venting and post-launch securing was complete.
And SHYE post-liftoff securing is complete.
Roger.
Now passing 15 minutes, 30 seconds into flight.
Fuel 1, LC.
Fuel 1.
Looking for status of cross-country LH2.
Minutes in, RL-10 continuing to perform well. Chamber pressures and injector pressures look good. Vehicle body rates remain stable. Fuel and oxidizer tank pressures on the second stage continuing to remain at stable conditions. Now passing 16 minutes, 30 seconds into flight. Approximately 3 minutes remaining in the first burn of today's mission. ACS tank pressure continues to remain stable. Fuel and oxidizer tank pressure is also looking good. Vehicle battery voltages remaining stable. Chamber pressures and injector pressures on the RL-10 continue to look good. Now passing 18 minutes into flight.
This is Delta Mission Control at T plus 18 minutes, 30 seconds. The Delta IV rocket carrying the WGS-8 satellite lifted off from Space Launch Complex 37 at 6:53 p.m. Eastern Daylight Time. We're now approximately 2 minutes away from completion of the first of 2 planned RL-10 engine burns. The mission will then enter a 10-minute coast period, followed by restart of the RL-10 engine. Let's join Patrick Moore for mission progress.
Into flight, approximately 1 minute remaining in this burn. Chamber pressures, fuel and oxidizer injector pressures continue to look good on the RL-10. Vehicle body rates remain stable. Now passing 19 minutes, 27 seconds into flight. Standing by for SECO 1 momentarily. And we have SECO. The RL-10 has completed the first burn of today's mission.
We just heard Patrick Moore announce the successful completion of MECO 1. I'm joined now by Arvel Chappelle, who is the Integrated Project Team and Systems Engineering Lead at Boeing. Arvel, thanks for joining me.
Thanks for having me, Mike.
So can you describe your role at Boeing?
So for WGS, my role was the IPT lead and the system engineering lead for the phased array antennas, which are part of our satellite. So in that role, I was responsible for not only the technical performance, but also the budget and the schedule.
So we heard Captain discuss about secure communications.
Right.
Can you describe how you build and design those features into WGS?
Well, you know, it all starts with the mission, right? So we get the mission from our customers. So they tell us, in this case, we want to build secure communications and we want it over a certain bandwidth. So from there, we take those mission capabilities and turn them into requirements. From the requirements comes design, and then comes the manufacturing, and then we test to make sure that we meet the requirements that were given.
So you mentioned building and testing.
Mm-hmm.
Can you expand on that a little bit and provide some background?
Well, the things that we do during tests are to simulate the environment that the satellite's going to be in. From the launch environment, which we just witnessed, for the vibrations and the acoustics that we get during the launch environment, also to the space environment. So we have radiation that we have to protect from. We have a lot of other stuff that we have to test for. So our goal is to stress the satellite and put it through the paces of our predicted environment. And in a lot of cases, we go well and beyond above what we actually predict. But the thing to remember about the things that we do when we design, build, and test these satellites is it's not just about the technical capabilities of what we do, but there's a lot of joy and pride that we have in actually putting these things together. So we take our job very seriously, so to the point where it's not just a job. I can speak for myself and also for all the other Boeing employees who are listening right now in the S24 cafeteria back at the Satellite Development Center. We take our jobs very seriously because we know it's not just about providing a tool for a customer to use. It's actually about protecting Americans and protecting American lives. So we take our jobs very seriously.
Yeah, absolutely. The importance just can't be understated.
Right, right.
So Boeing has a robust history of over 50 years of developing both commercial and military satellites.
Right.
Can you share some of the features that make WGS unique?
So the WGS satellite is a very cool looking bird. So here I have a model, and some of the highlights that I want to point out are the Ka band antennas, which I'm pointing to now, the channelizer, which you can't actually see, but it's deep inside this cavity of the payload. Our new Generation 6 channelizer is new on F8, and it provides double the bandwidth. My most favorite feature of this bird are these two phased array antennas right here. So these are the part that I was responsible for. So if you look very closely, you can see little squares on there, and those are actually, each one of these squares represents an antenna, and we phase them up together to form a larger antenna out of these small little rectangular horns. So what that allows us to do is if I can use this pin as an example, allows us to send beams out that you saw animated in the videos prior to us going on. It allows us to shoot beams out in multi-directions, and that allows for agile communications that we can shape, and it also allows for us to do our anti-jamming capability that was discussed in the anti-jamming video earlier. So that's just some of the features of this guy.
That's amazing. Thank you so much for sharing all that, and we're honored to be able to give you a ride today.
Oh, thank you. We appreciate it.
Let's return to Patrick Moore for the upcoming mission event.
Now passing 25 minutes 30 seconds into flight. Approximately 4 minutes remaining in this first coast period prior to the ignition of the second burn of today's mission. Now passing 27 minutes 28 seconds into flight. Approximately 2 minutes remaining in this first coast period. "28 minutes 30 seconds into flight. Standing by for ignition of the RL-10 in approximately 1 minute from now." We have ignition and full thrust on the RL-10 engine. Chamber pressures and injector pressures looking good. This is the second burn of today's mission. This burn should last approximately 3 minutes. Vehicle body rates have damped out nicely after initial startup transients. Chamber pressures and injector pressures continue to look good on the RL-10 engine.
This is Delta Mission Control at T plus 29 minutes 56 seconds. As just reported, the RL-10 engine has been restarted. This second burn will last about 3 minutes. Our next event, MECO 2, completes the engine burns for this mission. Here again is Patrick Moore.
15 seconds into flight. Now passing 30 minutes, 30 seconds into flight, approximately 2 minutes remaining in the second burn. RL-10 continues to perform well. Chamber pressures and injector pressures look good. Vehicle body rates remain stable. Now passing 31 minutes into flight. Now passing 31 minutes, 30 seconds in. Standing by for cutoff of the RL-10 in approximately 1 minute from now. RL-10 continuing to perform well. Fuel injector, oxidizer injector, and chamber pressures all looking good. 31 minutes, 50 seconds into flight. "32 minutes, 15 seconds in. Standing by for main engine cutoff momentarily. And we have main engine cutoff of the second stage engine.
We've just heard confirmation of the successful cutoff of the RL-10 engine. The mission is now in a 9-minute coast phase, flying above Western Africa. Separation will occur over the southeast coast of Madagascar, approximately 50 degrees east longitude and 18 degrees south latitude. Welcome back, Captain. Let's dive into our Twitter questions and answers.
Sounds good.
So trivia question 1 was, WGS-8 is launching on a Delta IV Medium Plus 5.4 configuration rocket. What date and mission marked the first launch in this configuration?
Well, the first Delta IV Medium Plus 5.4 rocket launched WGS-3 on December 5, 2009. By the way, fun fact, all of the Delta IV Medium Plus 5.4 missions have been WGS missions. Congratulations to @ThatAsianKid123 for being the first to answer that trivia question correctly. The second question was, to what orbit will the Delta IV deliver the WGS-8 satellite?
The Delta IV will deliver the WGS-8 satellite to supersynchronous transfer orbit. Congratulations to @MatthewJLB for winning that one. The third trivia question was, how many independent coverage areas does WGS have?
WGS has 19 independent coverage areas, 18 of which can be positioned within its field of view. Congratulations to @TheNASAMan for being the first to with the correct answer. And the fourth and final trivia question was, from which Air Force base is the WGS constellation controlled?
The U.S. Air Force 3rd Space Operations Squadron at Schriever Air Force Base in Colorado Springs operates the WGS constellation. Congratulations to JP Major for winning that trivia round. Well, that was fun, Captain, and I'd like to say good job to all of our Twitter participants. We're approaching spacecraft separation, so we'll get back to the mission soon, but before we do, let's take a look at a video celebrating United Launch Alliance's 10th anniversary, which happened last week.
liftoff of the United Launch Alliance Atlas V rocket carrying the 7th GPS-2F satellite for the United States Air Force. Have ignition of the RS-68 main engine.
And liftoff.
Buell significantly enhances communications for U.S. forces on the move.
We have liftoff. The Global Positioning System provides worldwide positioning, navigation, and timing services from military and civilian users.
3, 2, 1. We have liftoff.
Liftoff of the Atlas V with T-Drizzle. Liftoff of the Delta II rocket with Canaveral.
Mars lander has touched down on the red planet.
Liftoff of OSIRIS-REx.
Liftoff. The dawn of Orion. We have liftoff.
Liftoff on the shoulders of Atlas. The SS Deke Slayton II orbital ATK Cygnus spacecraft soars toward the International Space Station.
We have liftoff.
Now back to Patrick Moore for our final mark event of the evening.
This is Delta Flight Commentary at 40 minutes into flight. Just under 2 minutes remaining prior to spacecraft separation. Vehicle parameters continue to look good during the coast. Helium bottle pressures look good. ACS tank pressure looks good. and the fuel and oxidizer pressure, tank pressures look good. Now passing 40 minutes, 35 seconds into flight. Approximately 1 minute remaining prior to SVSEP. Now passing 41 minutes, 23 seconds. Approximately 20 seconds remaining until spacecraft SEP. And we have good indication of spacecraft separation of the WGS-8 spacecraft.
Captain De La Pena, we just heard Patrick Moore report a successful separation. Congratulations on the successful deployment of WGS-8.
Thanks, Mike. Obviously, today isn't about one particular organization or another, but instead the culmination of efforts between government, civilian, military, and government contractors. So congratulations to everybody involved, and congratulations to the Air Force, our nation, and our international partners on a successful launch today.
I'd also like to thank Patrick Moore for his participation in tonight's broadcast. For more information on this mission, go to ulalaunch.com or follow us on Facebook and Twitter. We'll leave you now with another look at the liftoff of the Delta IV rocket carrying the Air Force's 8th WGS satellite. I'm Mike Underhill. On behalf of the entire launch team, thank you for joining us and have a great night.
Trophy ignition.
T-minus 10, 9, 8, 7, 6, 5, 4. We have engine ignition. 2, 1, and liftoff of the United Launch Alliance Delta IV rocket carrying the WGS-8 mission for the United States Air Force.